Hey everybody, my name is Sam Deiter. I'm one of the senior content creators out here at Epic, and today we're going to be talking about motion controllers. So before we jump in, I'm going to cover the topics really quick. So first we're going to talk about what motion controllers actually are, because I'm sure a lot of people have maybe heard that term, but might not necessarily know exactly what they are. We're going to talk about who makes motion controllers, what motion controllers can be used with UE4. We're going to talk about how to set up a generic motion controller in UE4. And then I'm going to go over how to set up the Razer Hydra, which you can see. I got the controllers right here, and I got the little base station here. And we're going to go over how to not only set this up, but first we're going to go over how you install the plugin. And thanks to Git Nano, who was the one who actually made this plugin for Unreal. This isn't something that Epic made. This was something that the community member made for us that we can then use here. You guys can use on your particular projects or whatnot. So with our agenda out of the way, let's go ahead and just jump right into it for our first topic. What are motion controllers? Well, motion controllers are devices that can have their real-world locations tracked and recreated in the digital world. And basically, this right here, this is a motion controller. Now, this is the Razer Hydra, and I'm going to show you some examples of some internet images I found of other motion controllers. But basically, all these allow you to do is they allow you to interact in the virtual world in a more precise manner than you actually could with a mouse and a keyboard. They allow you to do things like maybe reach around an object like this. You know, maybe there was a box right here, and in the virtual world, I can move my arm around like this, or I can move my arm over, or I could do rotation, right? I could do tilt. So I have all of these different axes that I can utilize now that are very similar to how I would manipulate objects in the real world, but these motion controllers help me take that real world manipulation and target it towards the digital one so I can interact with things much how I'd be picking them up and rotating them around as I'm doing with my hands, but I'm doing it in 3D. And they are crazy accurate. Especially my favorite ones happen to be the Steam VR controllers. Razers are pretty good. What I've been testing, I've only been using them the last couple of days, but so far I found they're actually pretty good controllers. I haven't been able to test out the Move controllers or the Oculus ones, so I can't really comment on how good they are. But if they're anything like these guys, they're going to be super accurate. And it's really amazing to touch something with the Move controller in 3D. So who makes motion controllers? Well, right now there's Valve, who makes the Steam controllers. There is Oculus. They make the Oculus controllers. There's PlayStation, or Sony, I should say. And Sony PlayStation makes the PS Move controllers. And there are Razer makes the Hydra. So I'm going to show you guys really quick. I'm going to pull this over here on the screen. If we can click over to the monitor really quick, there's an image that I just want to show you guys. This is what the Steam controller is, Steam motion controller. And you see these little things right here are little sensors that the Lighthouse base stations pick up when the particular when it's within the VR interaction zone. And these little things right here, they're all over the motion controller. They help the computer figure out where this is in space in the real world and then translate that one into the digital one. And that's the Steam VR one. Now I'm going to show you the Oculus one, and we'll just click this back up here. Again, similar technology. You can see that we have some of these little tracking dots all over this thing, and this allows the tracking camera to better track where your hands are in the real world and then translate that one into the digital one. And next we've got the, this one's a little bit larger, the PlayStation Move controller. This is very similar to the regular PlayStation, I shouldn't say very similar, it is a PlayStation Move controller. I haven't been able to test these ones out in VR, so I don't know how well they function or not yet. I'm still working on getting my PlayStation dev kit. And the last one is the one that I just showed you at the beginning of this one, and that is the Razer Hydra. You can see it right here, and I showed it to you when the video was going, or I'm sorry, when the stream started. And this one is one that is available right now, albeit a little bit of expensive, but you can still find them. You can get them on eBay, you can get them on Amazon. You might have to search a little bit for it, but they are available. And this would be the best option if you're looking to get into developing right now and you really, really want to get in there, get a motion controller, figure everything out, then the Razer Hydra is going to be your best bet for that one. So what motion controllers can be used with UE4? So right now, what we support is we support the Steam motion controllers, which are these guys, the Oculus controllers, which are these guys, PlayStation, if you're a PlayStation developer, and the Razer Hydra. We support this with the community plugin. Now, Steam, both the Steam and the Oculus ones, you're only going to find the required components that you need for this, and we'll cover this in a second, in 4.9 and later. The PlayStation one, this one right here, this will work in 4.9, but if you're doing any development, I would hold off until 4.10 because there's going to be some more features that come online that make it much easier to interact with these guys. And the Razer Hydra, the plugin has only been compiled for 4.8. So if you try to put the plugin in 4.9, probably not going to work. I didn't try it at all because I know it wasn't programmed, or it wasn't coded, I'm sorry, for 4.9. So if you want to use the Razer Hydra, you're going to have to use Unreal Engine 4.8 or wait until they recode the plugin to match the 4.9 release of Unreal. So with a little bit about who makes them, who makes motion controllers, what they are, what they look like, and things like that, let's go ahead and look at how we actually utilize those inside of Unreal Engine 4. Let me just... let's see. Okay, so the first thing we're going to talk about, I'm going to talk about the Steam VR system. And you can see I have a little example map here. I'm going to pull up the Steam VR pawn really quick. And just forgive all that stuff down there. This is an older blueprint, an older method for setting this up. But we have completely streamlined how everything works in 4.9 with Steam VR controllers. So over here on my Components tab, you literally need 3 things in order to get this to work. You need a Steam VR chaperone, okay? And this you just type in Steam here, VR chaperone, there you go. You click on it, you'll add it as a component. And then the other thing that you're gonna need is you're gonna need a motion controller right here. So motion controller, and I just added an extra one. So you're going to need 2 of them. You're going to need one for the left hand and one for the right hand. And when you put it on there, don't forget to specify a static mesh. And the viewport, it's going to look like you have nothing there. And that's simply because we have it turned invisible over here, just so that when they're first sitting in the world, you don't see them, and they'll become visible once you start moving your hands around. But that's it. That's all you have to do in order to get this to work. Unfortunately, I do not have any Steam controllers, so I can't show you what this would look like in action. I have tested this because I built it when I had them, so this does work, but unfortunately I can't show it off. But what would happen is, as soon as I went to go play this level, my guy would be starting right here, and basically in my hand I would have 2 of these little balls right here, and have this one, and then I would have this one. And as I moved around, as I moved my hands throughout the scene, as I moved the controllers throughout the scene, you would see these 2 balls moving around as if they were attached to the top of my controller. And I literally just added a controller left, a motion controller component, 2 of them, and the Steam VR chaperone. And that is all that you have to do to get these to work in 4.9. You can come here and we can go to our project settings and our input, and then you can see I was messing with some of the Steam Touch settings over here, but you can come over here and you can map all of your inputs and your axes to do different things. Again, like a standard input, like a standard 360 controller. And that's the beautiful thing about this, is that we've really taken a lot of the work out of this for you. And now you don't have to worry about, oh, did I set this up? Did I forget this? All you got to do now for Steam VR is add the 2 inputs for left and right, and the chaperone, and that's it. You're ready to go right outside the box. I mean, if you're like, no, this sounds way too easy, it's totally true. It's that simple to get this stuff set up and running. let's see, what else do we have here? Yeah, I mean, that's it. My notes for this section is really, it's basically a paragraph because it is that easy. The other thing that I want to show you guys really quick is, haha, I have the motion controller components set up, all documented here on the website. The only problem was I forgot to put it inside of the inside the table of contents, so it didn't show up when you were looking for it in the VR section. Now, everything that I'm talking about today, all of this setup, how to get everything working, you'll all find it in this document right here, and we can have Alexander link it in the chat at the end of the talk here. But all of this has been documented, so I'm not going to be going over anything today that you wouldn't be able to find a document for on the internet or something like that. So the next thing we're going to jump into, with that out of the way, is we're going to talk about the Razer Hydra, and here's the web page for it. You can find it on our forums here, and I just downloaded the latest version, 4.8, and then a couple interesting things about settings that you have to do here. Give me 1 second. So let me show this in Explorer really quick and bring this over here. So motion controllers. Once you download that, there's two things that you're going to have to do. It's very, very important. So the first thing is you're not going to have a plugins folder. So you'll have to make a folder called plugins, right? And then you put the Hydra plugin inside of there, and you get your binaries over here. Oops, that button doesn't go back on this mouse apparently. You don't need to touch any of this stuff. You just need to put it here, put it in the plugins folder. The other thing that you need to do is when you start a new project, you're not going to have a binaries folder. You need to add a binaries folder and then add the two DLLs, the Win64 and the Win32. And that's it. That's all you have to do. If you don't add this binaries folder, the game will just start to crash and you'll be like, well, why is this crashing? And then do a little bit of research, you find out, oh, I need the binaries folder. This happened to me yesterday when I was trying to get this to work. If I would have read the instructions a little more carefully, I think I would have figured everything out. But in my haste to get everything like, oh my God, this motion controller is going to be so awesome, I, couldn't figure out what was going on. So remember, plugins folder with the Hydra plugin, binaries folder with the Win32 and the Win64 DLLs, so that the Unreal can see the Razer. So once you've launched Unreal, to see if everything is working, we're going to come up here, we're going to go to Window, we're going to go to Plugins, and my Plugins window has disappeared somewhere. There it is. And you can see Project, Input Controller, Hydra plugin, unofficial plugin for Razer Hydra motion controller. You can see it defaults to enabled, and that's it. It is good to go. Right now, I could start this up. In fact, let me do that. I'll start this up for you guys. So see, it says Hail Hydra right there, as you know that I've picked it up. And then I can run around. You can see that I can move this little green box. And if I click, I will put down a cube. And if I click on the other side, I will take that cube away. And the other thing that I set up is I have a 360 controller here. You might be wondering why I have that set up. It's because I was testing force feedback, which I'll show you guys how I put in there as well. So basically, when you, whoops, don't want to be staring at the dude like that while he's running. As you put stuff down on the ground, the force feedback will signify to the user that they've put something down within the world. It's just an easier way to make people feel like they're interacting. And you have such control with the motion controllers, but then to not get any tactile feedback when you bump into something or you hit something, it feels a little weird. And the rumble, while it doesn't make it feel like legitimate tactile feedback, it does make it feel like something is happening. It gives you a little bit more sense of immersion within the project. One of the other important things is, as you go to shut down, if you're using the Razer Hydra, I found that if you don't dock this, and there we go, see Hydra docked up there in the corner. If you don't dock that, the next time you come to play, your triggers might not work, things might not be placed in the right location. I was having tons of problems with this yesterday, and I found out, hey, you know what, if I dock each and every single time that I stop the game and then start it up again, I won't have any of these problems. So remember, if you're using the Razer, make sure you always put it back on the dock when you're going to restart your game through PIE. It'll just make your life a lot simpler. So let's see how I set everything up. Now we've seen how everything works, let's see what I did. So first, we have the plugins installed. We've got the plugins in there. We got the binaries in there. Now let's go ahead and look at my third-person character, because this is where I'm going to put the components for the Razor Hydra. So let me pull this up here for you. So first off, you notice that right out of the bat, I don't have the components up here, the movement components, and that's because the Hydra does this in a little bit of a different manner. One thing that's similar is that you need to add the Hydra component, much like you need to add the VR chaperone. And that's all that you have to add from here. The next thing that you have to do, which is completely different than any of our other VR implementations, is you need to come up here to class settings, and in the interfaces, you need to add the Hydra interface. And you just simply come down here and you can select it from the interfaces. And what that will allow you to do is it will allow you to get things like the event Hydra docked or the event Hydra undocked. And you can see when my Hydra is docked, it says Hydra docked. When it's undocked and ready to use, it says Hail Hydra. Just, you know, some little fun that we like to have around here. But the reason I did this is originally I couldn't figure out, is this thing working? Is it on? Is it off? Is it picking it up? So this was the first debug message that I picked up. Is it docked? This is the first thing that I tried. Once I got that working, once I figured that out, I'm like, okay, did I pick it up or has it been undocked? Then I got that message working, so I could figure that out. After that, the next thing that I started to do is I started to add the add and remove items. And basically, this is just really, really, really simple. What this does is on my Hydra left trigger click, it's going to spawn a blueprint, which let me click over to my my content browser here, and it just spawns this, which, of course, it came over here on the other side. Let's go to the viewport, which is just a simple box with collision around it. And in my event graph here, I have some very simple event actor begin overlap, which casts to my third-person character blueprint, which will then cast to enable the function to do rumble, so I can shake when I get some feedback. And that's it. That's all the logic for the box. And in fact, the whole thing will work without this right here. I just put this in here to give a little bit of force feedback again to help add to the immersion of the entire experience. So on my left Hydra click, we are going to from our spawn location, which I'll show you in a second, we're going to spawn a brick, and then we are going to add this to an array. And the reason I'm adding this to an array is so I can, like, you know, spawn 50 of them, and then I can get rid of 50 of them by pressing the right trigger click. So what happens on the right trigger click is it basically destroys the last object that was put into the world. So basically it's filling everything up in an array, and then it's going to remove the last item that's inside of that array or the last thing that you put down. There's a million different ways that you could do this, and I'm not saying that this is the best system. All I'm saying is this is a system that works for what I was trying to do. It's a little Minecraft-esque. Could have tons of improvements, but I think it gives a good jumping off point to test something out like this. So we've got our add items, we've got our remove items. This one down here, this is actually pretty cool. So this is placing the objects using the motion controller. If I came over here and I just played right now and I undocked these, you see how the square is moving around, or the cube is moving around? The cube is actually attached to this left-hand controller here. And as I move my stuff around in the world, I can affect where the boxes will be placed relative to that particular cube right there. Again, this is a very very simple system. It's not meant to design to be accurate, it's just meant to show us kind of some examples of what's going on. So it's not ridiculously accurate, but it's accurate enough for the time being. So basically, how I was able to interact with that, or how I was able to make that that box move around as if it looked like I was moving it around myself, is really, really simple. I have this event controller Hydra moved. So basically it's looking for, did the Hydra move? And here what I'm doing is I'm setting the spawn location of the particular setting the spawn location variable, to the location of that box, so I can get the box to spawn where I want it to. I'm checking to make sure that it is within the left hand, And then I'm just drawing a debug box, right? So that you can see the box around the area. Before, you could just see 2 debug boxes and they were just kind of moving around. I didn't think that was that cool. That's why I added the functionality to spawn something when you clicked, to show, how you can still move around like a regular character, but then use the motion controller to do something that you wouldn't be able to do, or get some type of interaction that you normally wouldn't be able to do with a simple mouse and keyboard or a 360 controller. Let's see, whoops. And so here's my rumble logic. Basically do rumble, which was a custom event. And then I get the player controller, I cast to my player character, and then I play the feedback rumble effect, which, excuse me, which is right here. Of course, I keep swapping the windows around. Basically, all I did is I just started adding keys. It's really easy to add a key. Just click here, you add key, and you can move around. You hit delete, you can delete a key. And basically, I'm just saying, we're going to go at time 0.25, we're do a value of -50. At 50, or time of half of a second, we're going to do a value of 50. 0.75 back down to -50, and then back out to 0. So we get this really big rumble. This is all stuff that is already inside of Unreal. You don't need any extra plugins or anything to do that. You can come here to miscellaneous, and force feedback effect will make you a new feedback effect. 1 second here. So this guy, there we go. So we have our rumble logic, right? This is pretty simple. And then, as we showed you before, the rumble is on the brick. So I say, when I overlap this, I'm going to cast to the third person, and I'm going to run this function. And that's pretty much it. I'll make this project available. It might sound complicated, but it's very, very simple. There's nothing more to it than this, to the rumble logic. It was like one of the easiest things I had to set up the entire day for this entire talk. Let's see, what else do we have? Okay, one of the other things that I found out completely by accident is there's actually something kind of cool you can do here with editing your inputs. So we're going to go to our project settings, and we're going to go to our input. And you can see here I have, my Hydra left joystick Y is moving me forward. My Hydra left joystick X is moving me right. I'm using the X joystick to turn. So basically that means that when I come here, let me undock my Hydras. I'm moving this way. I'm moving this guy to move like that. So, to switch, to change the parameters, normally you'd have to come here, you'd hit escape, then you'd come over here to this, and you'd input your parameter, and then you'd play the game again. Well, one thing that I found out you can do is you can actually edit these properties in real time. So I'm just going to have this hanging off the screen here like this. So I'm going to go ahead and play. And I'm going to hit Shift F1 on my keyboard to activate my mouse. And I'm going to come down here. I'm going to type Hydra left, and we will change this to the joystick Y. Okay? And now if I pick my Hydras back up, you see I'm getting like the movement's a little funky, but I'm still able to move stuff around. So let me go back. Let me put these guys back down. I'm going to hit Shift F1 on my keyboard again. And I think this was Hydra left joystick. And I do believe it was X before. And if I come back in here now, and you see I got my X control back, where I can go up and down with the X axis like this. And then I can go, hold on. No, I'm sorry, up and down with the Y, back and forth with the X. Sorry about that. And I can still place my cubes and all that stuff. So this is a really great way if you're trying to figure out which way you want something to go. Like, what do I want this stick to do versus this one over here? Am I really happy with the speed or the scale at which something is moving? Doing this by hitting, making sure these guys get docked back, hitting Shift F1, then coming over to the screen and adjusting whatever parameter I need here, all while the game is running, is a really, really, really great way to super tweak and refine your control system without having to spend a lot of time getting into the game, shutting it down, putting in the settings, setting something else new, going in that entire loop. You can just do this in real time now. And this is something I just found out yesterday I could do when I was trying to edit the Hydra files. I'm sorry, when I was trying to make the the Hydra blueprint. So, oops, it would help if I would stop. So, let's see, what else do we have we can talk about? Let's look at this. So if I come here and I type in Hydra, you can see I have all of the keyboard values and events and functionality and everything for the Hydra. Basically, you work with these inputs in the exact same manner that you work with regular inputs, like for something like a 360 controller or something like that. So there's not a lot of extra things that you have to do in terms of setup. The thing that you need to spend more brain power on is figuring out, how am I going to use this motion controller to do something that somebody can't do in a video game before? Am I going to figure out a way where they have to use the motion controllers to maybe move something aside, or are they going to have to use the motion controllers to I don't know, reach around something or reach over something or something like that? Because again, a lot of the stuff that I did to get this to work today isn't much different than the things that I can do with the standard 360 controller. The real hard part comes in, how do I use this new tech to introduce some new gameplay mechanic or some new type of interaction element that players want to have, and that's really, really, really fun to do. And that just requires a lot of testing, right? And that's I would say that is the hardest part about this entire thing, is figuring out how to use these controllers to do new and interesting things that people are really going to enjoy doing, other than setting everything up. Let me kick over here to excuse me, to 4.9, and oops, of course I opened up the wrong one. I think it's this one. Here we go. And I'm going to go over into my Steam VR. So now if we type in motion, we get all the motion controller events. We get, face buttons, thumbs, axes, basically all of the events that the motion controller can do. And again, in 4.9, all of this stuff is in there by default. Excuse me. So let me go back through my my notes really quick here, so we can make sure we got everything covered. So we talked about what motion controllers are. We talked about who makes motion controllers. We talked about what motion controllers can be used with UE4. And again, that's Steam motion controllers, the Oculus controllers, PlayStation Move controllers, and the Razer. That I know of that can be used. Now, there might be something else out there that's maybe new or something I haven't heard of that can be used with UE4. So if you know of something like that, or there's something you want us to look into, please post to the forums. We'll see what we can do. I can't make any promises. The next thing we talked about is how to set up a generic motion controller. And again, inside of Unreal, that's just adding 3 components. You need to add the chaperone, okay, the Steam VR chaperone, and then you need to add the motion controllers. Oops. Okay, and we add a motion controller right here, and you can see I have my motion controllers. Let's see, one sec here. Is there anything down here I need to? And nope, I think that's it. Yep, so we got one for the left and one for the right. Hold on. I thought... Okay, never mind. I thought there was a checkmark flag for distinguishing which one is the left and which one is the right, but I don't think that matters. And so we talked about how to set up the generic motion controllers. Went over that again really quick. Then we jumped into how to set everything up for the Razer. So we've got our setup right here. Okay. And that's it. And again, this was built off of the third-person template. So let me go ahead and kick over here. And now I've got a lot of questions. So let me jump into some of these questions. Let's see, what is the status on the PS Move integration? So PS Move integration, it's being worked on. There's not a lot I can say about it because you need to be an authorized Sony developer in order to get the required files from Sony that will work with UE4. However, once you have that integrated, the PS Move controllers work exactly like the other movement controllers. They, Unreal is device agnostic, so we don't support, the Razer or just the Rift. We support all 4 of them. We support the Razer, the Rift, the Hydra, and the the PS Move controllers and 360 controllers and Samsung controllers and Android controllers and all types of different controllers. So with that said, the interface for interfacing with those, since we have such a huge variety of them, makes it very easy. Because we have to deal with so many, we make it as generic as possible. So yes, you will be able to have the PS Move work, but you have to be a registered Sony developer. And the other thing is they will work just like the other motion controllers. So you're not going to have to learn anything new or learn something extra. You can take what you've learned from this today and from your own experience and then apply that if you do become a registered Sony developer. Next question was, considering that very few people have access to a Vive or Oculus Touch dev kit, can you recommend any alternatives for developing and prototyping? That's actually why I wanted to do the Rumble, because this doesn't do Rumble inside of it, but I know my 360 controller does. I wanted to get the Rumble at least working, get some remnants of it there set up and working, and then when I get something that has Rumble inside of it, like a Vive controller, a Steam VR controller, then all I have to do is just tweak the Rumble settings. I don't actually have to set everything up and make sure that everything works and all of that stuff. All I have to do is now just tweak the profile because I was testing it with my 360 controller. If you really want to get your hands on some motion controllers, I would suggest getting the Razer. The Razer Hydra. It's very good for what it is. One thing that I did find out about it and didn't realize this until earlier is that this is basically your pivot. Let me see if I can, yeah, there we go. This is basically your pivot right here, this little green ball. So you have to think of it as this is actually sitting inside of me, and then I work in 360 degrees around it. I didn't realize that until I was trying to do something else, and I had to end up reaching like all the way over here to get it to work. And that's when I realized, like, oh, I have it in the wrong spot. It should probably actually be more right here, but it's a little bit of a hard spot to put it in. But again, to kind of bring this around, even if I didn't have this to test with and I just had my 360 controller, there's still a lot that I could do. You know, I could go online, I could look up how many buttons it has, and I could say, you know, it's got 4 buttons similar to my 360 controller, so you know what, I want A to jump and I want B to do this. So you can use other devices to test your stuff out and kind of mold your ideas. You don't have to have this hardware specifically to start on your project, but once you get about halfway through your project, then you're going to start needing the hardware. But like I said, right out of the gate, it's not necessarily needed to get you going or to get you started on the right direction. About the PS Move support, is this only going to be for PS3? It has PS4 games. Will you need a PlayStation to test out the Move, or will you be able to make PC games with the Move? Last question, have no idea. I cannot answer that one. The other two, I know for a fact it will be for PlayStation 4. If you're on 4.9 right now, there is some update code that you need to do, a little code patch to get the integration to work. On 4.10, you won't have to do that. It'll just work right out of the box. But again, you have to be a registered Sony developer. So there's not a lot I can do for you about that. I can't give you the code or anything like that. You'd have to get it from Sony when you become a registered Sony developer. Here's a good one. This was a good question. When using a Vive, you are prevented from running into walls by a virtual representation of your play area's boundaries. It's the chaperone system. Does UE4 handle the rendering of these walls, or is it the responsibility of the game? If it's done by UE4, can it be disabled or replaced with a custom style? So the chaperone system, for those of you who are not very familiar with it, what it is that is Steam's VR system for handling all of the stuff like your hard bounds and your soft bounds and your room, how big your room is, and the controllers and how they work and all that stuff. This is basically the guts of the Steam VR system. And in Unreal, you put that chaperone component on your player object, and then you put the 2 motion controller, one for your left and one for your right. Now, what that Steam chaperone does is when you first launch Steam, you'll have this thing called the room configurator. What the room configurator does is it allows you to set where your room is. So it shows you where your trackers are, and it'll show you where your headset is. And then using one of the controllers like this, you can set the bounds of the room. So I could set the bounds of the room to be, or I could have a very large room, but I could grab the bounds and I can move them in to make my play space smaller than the actual extent of the rooms. Now, all of this stuff is handled explicitly by the chaperone system, right? It's all set up, it's all handled by there. So you can't, there's certain things that you can't affect, but more importantly, there's certain things that you would not want to affect. And the last part of this question is the real reason why I wanted to talk about this in the first place. You should never adjust something that just to make it custom, just to make it custom. People who use Steam VR are going to be extremely used to the little, when I checked it last time, they were blue, but they could have changed this color. There's these little blue lines that come out like this. And those blue lines signify that you are about to leave the interaction area. Now, that is standard across any game that you play that uses Steam VR. So no matter what game I'm playing, as soon as I see those little lines, I immediately know, oh, I'm about to step outside of the interaction area. I need to be careful, or I need to take a step back, or I might need to adjust pull my headset up and see where I am in the room, and then readjust myself. Why I'm so passionate about this is if you change that, what you're going to happen is somebody is going to have something in their game that goes wrong. They step out of the bounds. They don't see that you have maybe changed it, or you've turned it off, or you've given them some other type of indication that they've lost tracking, they've stepped out of the bounds. They're not going to see that. They're not going to understand it, and they're going to think, oh, the system is broken, or it doesn't work well with your game, or a million other things that can come sprouting out. So if you don't have to change it, which you don't, it handles it all for you. So worry about building something else. If you don't have to change it, don't change it just for the sake of changing it, because it will open up a whole other world of problems that you might not have ever considered before. So on the VR forums, one guy did something that was actually kind of cool. He took the Lighthouse VR and basically implemented it so that it would show you the scanning pattern inside of UE4. So you could see how they were sweeping across the room like that and like this. That's something that you could do. You could show people maybe in the editor, or show them where the tracking cameras were, or maybe make the chaperone system, because the chaperone system, the hard and the soft bounds, and they only show up when you actually get close to them. So you might be able to do something in Unreal is like, maybe show me where they are all the time within my world so that I can design around them or something like that. But you never want to change the look of them, because people are going to get used to that. And then when they come to play your project and they don't see the standard look they've seen in every other project they've played, they're not going to understand what's going on, and they're going to be like, oh, your thing is broken, or my headset's broken, or it's just a crappy implementation. And none of that stuff is true at all. It's just you did it slightly differently than they're used to, and that's going to interject some problems for you. So stay away from doing things like that. One other thing I wanted to touch on. So you might have heard me say the term soft and hard bounds when I was talking about the Vive. And the difference between the two is this. The soft bounds is basically the area in which interaction can happen. So the soft bounds, say, for me, would be the area within this chair, okay? And this is where I can interact, I can move my arms around, up and down and things like that. The hard bounds are the areas outside of the soft bounds, which means if I go into this area, I will completely lose tracking. So for me on this chair, the hard bounds would be maybe about this far outside of my chair over here on the couch. If I put the motion controller over here like this, I should see some blue lines coming across my screen, and all of a sudden everything will get really choppy. The camera might jump around like this. You might see the motion controller that I have in my hand moving around all rapidly because I've lost tracking. It doesn't know where it's going to go. So that's again, the soft bounds is the area in which the play can take place. Hard bounds is outside of the play area where you will lose tracking. And this is some terminology that's specific to Steam VR, but the concept of the hard and the soft bounds is something that's universal to anything that uses some type of device to track motion in the real world. You will eventually go out of it. Oculus, you lose tracking, which is more or less the same thing as stepping in and out of the hard and the soft bounds. And let's see, what else do we have here? Do you know if the chaperone system allows for a virtual inset, i.e. can you set up the lighthouse boxes all the way in the corners, but then define a smaller play area to account for TV and furniture? Yes, you can. You have to do that within the Steam VR configuration tool, and the tool's pretty cool to use. You put your headset on, you grab your two motion controllers, and then you literally points in the world, you click and grab, and you move that to the extents as far as you can, and then you grab this one, and you move it over here, and then you grab the one that's behind you, and you grab the one that's in that corner. And you move them, and you can make the extents as large or as small as you can, slash the program will allow you to. Yeah, to account for things like furniture and stuff like that. But again, this is all done outside of Unreal, and as far as I know, that's not something that you can do inside of Unreal. It's something that you have to do within the Steam VR SDK that you can download from the Steam client. Sorry. Where's your universal motion implementation? Where's your universal motion is going in the midterm? Can you share features that will come next? I'm especially interested in auto device configuration switch, so you can set up your project and all the different motion controller bindings, and then UE4 will know what's connected and use them accordingly. Unfortunately, I don't know what's next with motion controllers besides the typical, like, we've made this run 5 times faster, or we've made it even easier to implement with buttons. I don't know anything big that's coming on because most of the heavy lifting has already been done and implemented, because you don't have to. Let me pull something up really quick. Let's see this guy right here. So this is how you used to have to do the all of the stuff that's handled in here and here. This is how you used to have to do it. So basically, you update the controllers for each controller. You have your controller left and your controller right. So you go through. You set its visibility. You set its location. This is the left. This is the right. You set its relative location and bounds. You just start drawing the tracker. You draw the hard and the soft bounds. Let's see. This is we'll draw the headset. These are some helpers for debugging, teleportation. We won't cover that. That's not. That's just to help you move around the world by pressing 1, 2, or 3. You'll teleport. But you used to have to do all of this setup right here. Oh, and the we got our input commands up here. These are for the teleportation. And then we have our main loop, which is basically event tick. We update the controllers, we draw the trackers, we draw the bounds, we draw the headset, we do the whole thing again. This is what you used to have to set up before we had the, basically we rolled all of this into components, and you just drop the component on top of whatever it is that you want to use. So we've been making massive updates behind the scenes as we have started to use this stuff internally. Are like, wow, we need to roll all of this and make it much easier for people to do. So these are some of the improvements that we've been making. It might not be something that you're seeing because you might not be using it as much as we are here and internally, but we are constantly improving the system and constantly working on it. So it's going to get updates. It's going to be adjusted. The other question that you had about the an auto device configuration switch, you can actually more or less do that inside of Unreal now. You could come up here and you could say, it's not going to work in this one. Let me see what I have here. Hold on. It's the problem of going. We'll just add leap motion controller component. So the problem is that this version right here is 4.8, and the controller stuff that I just showed you in this project over here is in 4.9. So in 4.8, the motion controller stuff wasn't ready yet. So what you could do is you could come here, and you see I have this stuff set up for the Hydra. Well, I'm going to get rid of this. Let's just say, event gamepad, I don't know, D-pad button up, right? And with D-pad button up, and I'm just going to do something like print, right? We'll just print a string, hello. So basically what I've done is I've said that when I press the up button on the D-pad, this button right here, I want to print out hello. Well, that's very similar to basically all of this other stuff that's inside of here. You see all of this stuff, and then if I scroll down here, you see I've got my gamepad input as well. So if I come up here and I play with my gamepad connected, you see I can do all this stuff. I can jump, I could even maybe do this. Let's try something crazy here. I didn't test this, so let's see if this will actually even work. So we're going to do gamepad, left trigger click. Okay. And we are going to All right, so basically, this is Hydra left trigger quick. Sorry about that. We want, no, it's because it's called gamepad. Gamepad left. And I do left trigger? Okay, so we'll do left trigger pressed. And hopefully this will work. There we go. So basically what I've done is when I click on the trigger, which is this one right here, I'm going to place the box. Or if I get my move controllers there, I can push this one and push the box, push the other one, and it'll get rid of it. So let's finish making this functionality work for the controller. So we'll do gamepad right. Oops. And it'd help if I could spell. Right trigger. Okay. And then, so we're going to move this up here. All right, we'll move this guy over here, and we'll say when he's pressed, we are going to destroy those boxes that we placed. So now what should happen is I should press it, press it, destroy it, press it, destroy it. And then if I grab my Hydras here, you press, destroy, press, destroy. So again, that functionality is already built in there. If I was to unplug this and plug in something else, and I had those things set up, that particular device would start working. Now, that's not to say that you might need to implement some type of user interface elements so that the end user can say, you know what, I'm going to use a 360 controller, or I'm going to use this type of motion controller or something like that. Like, while there might not be a complete system in there that you just have to slot stuff into, all of the building blocks are there, and I guarantee you could build this system without having to modify any of the source code inside of UE4. I bet you could do all of this with inside of blueprints. So let me see, what else have we got here? Will we see some Vive action? No, because unfortunately I don't have a Vive. If I had a Vive, I would totally show you guys, because that's one of my favorite ones to use. The motion controllers are so freaking accurate. Like, even in 3D, if you have some exact models of them, you can put them together like this close, and they will touch. They won't intersect. They will literally touch each other, and it's a one-to-one. It's really, really weird to see that type of precision inside of a virtual world. Let me see. How do you set relative world space of a motion controller to be relative to an HMD? That I'm not. Do you mean like relative? I'm not sure if you mean like relative to the head rotation, or what exactly you mean relative to. Because it's a component of your pawn. Let me think about this. I don't know off the top of my head, but I'm pretty sure all you have to... I'm pretty sure most of this is actually already handled for you. Again, we were trying some stuff out. We found out that it was a lot of heavy lifting in order to get this off the ground. So it was something that we... could have been something that we rolled in under the hood. I can... hold on, Alex is writing something here. Okay. With Alex's note, I see what he's doing, so... I see what he's asking. So basically what we did is we did a little bit of vector math, and that you'll see that in this right here, the spawn location, the transform location, and then we added, hold on a second, I forgot what this was right here. Oh yeah, it's because it's over here somewhere. Where'd it go? Hold on one second here. Yeah, here it is right here. So we get the, what we did to stop the box from being spawned like behind the player. It's always spawned in front of him. So we got our player pawn. We got the forward vector of him. And then we added that by 150 in the X to offset it by 150 units. And then we added that to our, from our position here. What we're doing is we're setting the spawn location to be around that box. So this is how we did the offset right here with a little bit of vector math. Depending on what you want to do, though, I mean, this is a very specific example for this example. Doing any more than that, I'm not really sure because I just haven't done anything. I haven't run into an instance where I need to do that. This can be something that I'll make sure to make a little note about this here, and we can ask a little bit more about this on the forums. Give me 1 second here. Make sure you guys get all the answers that I might not know. So, ask a little bit more about this. So, why is the Steam VR blueprint a spectator pawn? Let me have a look really quick. The only reason I can think that it was a spectator pawn is that you don't need some of the things that the regular player character has. Like you might not need the ability to jump, or you might not need some of the turn the turn functionality. I haven't had any issues setting it up with the Steam or with the spectator pawn. In fact, I didn't actually know it was using the spectator pawn until you pointed it out, because it works exactly the same as the regular pawn, and I wasn't having any issues with it. I don't see any reason why it wouldn't work. Why it has to be the regular pawn. Why it doesn't have to be the spectator one specifically for Steam VR. Again, I don't have a Vive right now, so I can't test because this was made when I was out in Seattle. We made this particular one. So I could get an idea of how everything is working, how this whole thing works all together, and everything was working properly. This could have been a slip up, but the reason I didn't catch it is because everything was working. So, you know that I know this probably doesn't provide you the best answer, but there wasn't really anything. Sorry, I just got logged out of my my document there. 1 second here. Let me scroll back down to the, where were we at? So yeah, I haven't found any reason why it hasn't worked, but I haven't tested it extensively. You know, I just got this up and running to try to get everything to work, because you can see that this guy over here, he's a regular pawn. This dude over here, he's just a regular blueprint based off of the character. So, any design tips for using VR? There are a lot of tips. We have some on our website located in our best practices for VR section. Some things that you are actually, here's actually a really good one. Reading the Oculus also has put a lot of time and scientific research into how you interact or how you should set up VR experiences. And all of that, you can find all of that information on their website for free, or it used to be for free. It's in a PDF. It might have gotten filtered down. You might have to do some serious Google searching to find it, but it is there. And one of the things they said in there is that people who do third-person VR experiences have a hard time associating themselves with the experience, and it could lead to motion sickness and things like that. I found out actually, you know, first I was like, okay, yeah, this makes sense. And then I actually tried some third-person VR experiences, and I have to say that is not as motion sickness inducing as I thought it would be, which means that while it still will induce motion sickness in the correct circumstances, one of the things you have to be super mindful of when you're developing stuff in VR is, first off, when you're testing out, does this give me motion sickness? Because if it gives you, the developer, motion sickness, it's going to give the little old lady on the street that you try to have this, she's just going to throw up everywhere. It's going to be like, it's going to look like a fraternity house in there. The problem with giving you advice about developing for VR is because it's so new, because it's such cutting edge stuff, things that I say today could end up being disproved tomorrow. So the key to this entire thing is to test, test, and test, and make sure you test with people that don't use VR. Ask your next door neighbor, ask the secretary at work, ask your mom, ask your grandma, to put this stuff on, to try it out, and see if they in fact get motion sickness or they don't get motion sickness from this. I don't want to tell you, no, you shouldn't do this, because there are no rules for VR, in my opinion, that are written in stone right now. There's a few things that we know that you shouldn't do that will cause motion sickness, but it's so new that not a lot of people have tested it, so we don't really know exactly what will cause motion sickness versus something that won't. And this touches all aspects of design. So the only advice I can really give you about this is to test, and test often, and test with as many people as you possibly can. Will there be a training stream in the future for Oculus? Sure. I mean, it's really, really simple to set up. But I guess we could have a training stream when I get an Oculus to go over some of the things that we've learned, or maybe some design tips, maybe from Nick Donaldson or Nick Whiting or Ryan Brooks or some other people who can come on, maybe give some design tips or things like that. But we'll see what we do. See. How can I access Rumble for Vive controllers from Blueprints? This is actually pretty freaking simple to do. Because how I got the Rumble to work on this is exactly how I got the Rumble to work on everything else. So let's go over here. So we're going to go to my test content. So first off, I have the Rumble, right? And basically the Rumble, it affects large, and then I've got some min and some max values. The one on my other project goes for a second. This one looks like it goes for almost 2 seconds. And to make a Rumble asset, you just right-click in the generic browser. Under Miscellaneous, Force Feedback Effect, open it up. We're going to disable these channels, and we effects large only. And then you can right-click, and you can add a key, move it around, add a key, move it around. Okay, so now that I have my Force Feedback asset, we need to set up what we want to do when Force Feedback is applied. So on this particular project, I want it to be when you touched one of these balls, I wanted the controller to shake. So in here, I've got on an event actor begin overlap. So when this is overlapping, I'm going to cast to my Steam VR pawn, and I'm going to initiate the do rumble function. If I double click on this will bring me over to my do rumble function. And the do rumble function is literally custom event. So that's, you can just come up here and do custom, add a custom event, and then you name it whatever. And then, that's a horrible whatever. There's no T in there. Then you just start, we come out here, we'll go cast to player. Oops. What was it? Hold on. Player controller. I have that memory of a goldfish. So we do cast to player controller. So that's going to cast to our player controller. And we've got get our controller, which our target is our pawn. And then if the cast succeeds, we are going to come down here, and we are going to play our force feedback effect. Right here, we have the force feedback rumble effect, which if I click, you see it's this one right here. So it's the same thing that I did before. And that's it. That's all you have to do. And if you can get it to work on the 360 controller, it will work on your Move controller. Funny story about that. I was here late one night doing something, and all of a sudden my desk starts shaking like a madman. It's like, and I'm like freaking out because I don't know what's going on. And I was doing something with this particular demo right here, and I had forgot that I had my controller plugged in, so my controller is vibrating like a madman on the desk. And it's because I had this rumble set up, but I had no Vive plugged in, no headset, no anything like that. And again, that's just kind of goes to show you how powerful our input system is. I made the input with another device completely in mind, never even tested it with the 360 controller. And then when I had my 360 controller plugged in, all of a sudden everything started working. You know, this thing started shaking like it was supposed to at the right frequency and the right intensity. And that's actually pretty cool because I didn't have to set anything else up. I set this up once and it worked for all the devices that have the Rumble functionality put inside of them. Let's see. Are there any limitations on the number of blueprint passes that can take inputs at one time? I have no idea. I would suggest maybe posting that question on the forums. Keep fat fingering the mouse buttons over here. Sorry, questions went away. Let's see. Yes, I've got it. Is there some way to figure out how high off the floor the headset and motion controls are? For instance, PS Move and Oculus cameras will be placed in a variety of different locations and heights. Is there some easy way to handle this? This I'm not 100% sure about because I don't know how exactly the PlayStation does the center of the room compared to like how the Vive does the center. And since the Vive can be a seated or standing experience, and the same with the Oculus, you could have where your base is in the world could be slightly different. This is not a super easy question to answer because half of this. Oh, it looks like so. Let me restate the question again. Is there some way to figure out how high off the floor the headset and motion controllers are? For instance, PS Move and Oculus cameras should be placed in a variety of different locations and heights. Is there some easy way to handle this? This almost makes it seem like you would have an experience where someone's using a PlayStation Move and someone's using a Vive. And I don't think that we've ever considered that or coded for that because you wouldn't. It's kind of a hard question to answer because you would never have a Vive that you would then kick into a Sony experience. You would have like. You would say, you know, I have my Vive, which I'm going to use, and then I have my Morpheus, which I'm going to use in a different experience. You wouldn't really combine them together, so you would have your project already set up for what head-mounted display is plugged in and which head-mounted display is currently active. So if I have my Oculus plugged in, I'm not going to get the Sony stuff, and I'm not going to get the Hydra stuff. I'm just going to get the Oculus stuff. So I hope that answers your question a little bit. If you would like some more in-depth detail about it, I would highly suggest posting on the forums about it because we're running into a little bit of territory where things that I don't know everything, unfortunately. I wish I did. Let's see, what else have we got here? So is it possible to add IR markers in UE4 for tracking, or does this need to be done in Steam stuff, Riff SDKs? And will they be adapted to be able to take dynamic inputs like this? This, to add IR markers, and then, no, you wouldn't be able to do this inside of Unreal, because Unreal just reads data from the camera. It just gets the camera data. As far as I know, we're not pumping anything back out to the camera. The camera would need to know, or the SDK would need to know, like what I'm supposed to do with this particular information that I get. Let me see what else. Okay. So let me say this again. Sorry for the mumbling. I'm trying to think as I talk here, so apparently I mumble when I do that. The question is it possible to add IR markers in UE4 for tracking, or does this need to be done on the Steam/Riff SDKs? I'm just reading this and thinking about it again. It's like inside a physical level. Most likely not. Inside the real world, definitely not. It would have to be something that the SDK would know about, because they would see these IR markers and they wouldn't know what to do with them, because they would be maybe like a different color, or not different color, but they wouldn't know what to do with that particular information because they're not looking for that information. They're looking for another type of information, if that makes sense. And it looks like we are out of time. So that is it that I have for you guys today. If you have any extra questions or anything like that, please post them to the forums, post in the VR section, or you can post some of your questions. I'll be checking the thread for this particular page the next day or so, and then if you got any more questions after that, please post them to the forums. I'll see what I can do about linking these particular projects so you can have a look at them. And if you'd like to know anything more in detail, just hit us up on the VR forum. So that's it. I hope you guys enjoyed the stream. I hope you learned a little something today. Thanks for tuning in, and we'll see you guys next time.